Surely. Hello. 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 ಮಾತಾಡ್ರಿ ಯಾರಾದ್ರು.
Yes, good morning, students. So, last class we were discussing about the general concepts of organic chemistry. Yeah, we were discussing about the IUPAC nomenclature. Then we had started with isomerism. So, based on that IUPAC nomenclature, we had solved some examples, right? We had solved some questions. So, next we'll start with electron displacement in organic compounds. Okay, so what do you mean by electron displacement? So, electron displacement occurs when electrons move towards one side or part of a molecule, okay, towards a one part of a molecule. So electron displacement in organic compound. So we are discussing about the electron movement, okay, in a organic compound. So electron displacement in an organic molecule may take place under the influence of an atom or a substituent group or in the presence of a attacking reagent. So here, what happens? The electrons, in the presence of some attacking reagent, it will tend to pull towards one side, okay, towards one side or one part of a molecule. So we'll see what the types of electronic displacement. So the first is inductive effect. So what do you mean by inductive effect? So it is a permanent displacement. So this type of effect is a permanent displacement of electrons along the chain of carbon atoms due to the presence of some electron donating or electron withdrawing group. So this is the meaning of inductive effect. So what do you mean by inductive effect? So this is a type of permanent displacement. So in which the electrons so they are pulled by the electron donating atom. So because of the presence of electron donating or electron withdrawing group. So which are the electron withdrawing or electron donating group? So the halogens, okay, halogen Cl minus. So so Cl minus, F minus, right? So these are the halogens, especially the halogens which are electronegative in nature. So these electron donating or electron withdrawing groups. So in this present, halogen, then your alkyl groups. So based on that, the inductive effect it occurs. Okay, so it occurs. So example, it is given CH3, CH2, Cl. So this Cl is what? It is an electron withdrawing group. Okay, electron withdrawing group. It withdraws the electron. So as it is highly electronegative in nature, what it will do? It will tend to pull the electron towards itself. Okay, so as a result, there will be development of partial negative charge on Cl minus. So beside Cl minus, the CH2 group which is present, it will get partial positive charge. So as you go further, okay, as you go further, that is to CH3, the partial positive charge increases. Okay, so this is a inductive effect. So note that this is a permanent effect. Inductive effect, it is a permanent effect. It is distance dependent. It depends upon the distance. Okay. So it is operated to what type of bond? It is operated to sigma bond. It is negligible after 3 carbons. Okay. After 3 carbons, the you cannot see the this. Okay. It increases. It decreases. Okay. So it is negligible after 3 carbon atoms. So what are the types of inductive effect? So there are 2 types of inductive effect. One is first is negative inductive effect, and the second is positive inductive effect. So first we'll discuss about negative inductive effect. So what do you mean by negative inductive effect? So the atom or group which withdraws electron clouds is known as negative inductive group, and the effect is called as negative inductive effect. Okay. So the atom or group. So here you can see these. This is a decreasing order of this negative inductive effect. So these are the atoms. So these are all what? It is electron withdrawing groups. So what it will do? So these are the example of electron withdrawing group. So these are they are placed in the decreasing order of. So this is what? So this is nitro group will be having a more. So it will show the most withdrawing power. So it has a most withdrawing power than that of this hydrogen. Okay. So the atom or a group which withdraws electron clouds is known as the minus inductive effect. And this so these are the decreasing order of the, this is the decreasing order of their negative inductive effect. So next is positive effect, positive inductive effect. So which are the groups which releases or donates? Okay, the group which releases or donates electron is positive inductive group, and the effect is called as positive inductive effect. This is the decreasing order of positive effect. So you can see here, right? So this is the decreasing order. So if it is CH3 thrice, okay, here CH3 twice, CH2 CH3, and CH3 is greater than H. So this is the decreasing order of. So when negative inductive effect is shown, when you have electron withdrawing groups, and when positive inductive effect is shown, when you have electron donating groups. Okay, electron donating or releasing group shows what? Positive inductive effect. So what is the application of inductive effect? So acidic strength. So negative effect, negative inductive effect increases the acidic strength. So you can see. So we had seen the trend. Okay, we had seen the trend here. You can see. So nitro group. So which are the example given here? One is your, here you can see. So here is nitro and fluorine. Okay. So here you can see. So nitro is most, what you say, it has more power of electron withdrawing group. Okay. So it is the most, it is having the more, the stability is more here as compared to that of fluorine. So what is said here? See here that, so minus I effect increases the acidic strength. So nitro group, here you can see nitro acetic acid is more. Okay, it shows more acidic strength than fluoroacetic acid because of what? Presence of this particular electron withdrawing group. Then basic strength is shown by what? So whenever you have positive inductive effect, it increases the basic strength. So this is the example. Methylamine is more basic than the ammonia. Okay, so one of the H, you can see one of the hydrogen atom in ammonia is replaced by methyl group. So it is what it is here, you can see. So what happens, it is a electron donating group. So based upon the electron donating group, what it will do, it will increase the basic strength. Okay, so these are the applications of your inductive effect. So next is electrometric effect. Okay, electrometric effect, so that is E effect. So temporary transfer of pi bonded electron pairs from one atom to another atom in presence of attacking reagent is known as electrometric effect. So here you can see, this is an example is given. So there is a pi bond. So there is transfer of the electrons from pi bond from one atom to another. Okay, in the presence of attacking reagent. So there is an attacking reagent. So in presence of attacking reagent, what is happening? There is transfer of this pi bonded electron pair from one atom to another. Okay, so here you can see there is development of what? Partial positive and partial negative charges. So this is electromeric effect. So in this, there are two types. First is positive effect and second is negative effect. What do you mean by positive effect? In this effect, pi electrons of the multiple bond are transferred to that atom to which the attacking reagent gets attached. So here you can see the pi bond is getting attached. Okay, it is getting transferred to the, so here what is happening? Pi bond, you know, pi bond is highly nucleophilic in nature. Okay, it is highly nucleophilic in nature. So this will attack the electrophile, and thus there is what? The attacking reagent will get attached to the atom to which it is transferred. So from this bond, the pi bond electron, that is the transfer takes place. So this electron, that is electrophile, get attached to the atom where the attacking reagent it gets attached itself. Okay, so here you can see CH2 double bond CH2, right? So here the pi bond gets attacked to the attacking reagent. So this is what? This is a electrophile. So your electrophile gets attached where? So at the CH2. So this is the positive E effect. Okay, so what is there? Whenever you have pi bond, so that is highly nucleophilic in nature. So this will attack your electrophile. So this is positive E effect. So what is negative E effect? That is, in this effect, pi electron of the multiple bond are transferred to that atom to which the attacking reagent does not get attached. So here you can see, so here Cn minus. So in the previous case, there was an electrophile. Here you have a nucleophile. So this is so what happens here? The Cn minus will get attacked to this pi electrons, okay, on the pi electron cloud, and thus here you can see Cn gets attached here, okay, not to O oxygen atom, but it attacked to the where it does not get attached from where the attacking takes place. Okay, so in this effect, pi electron of the multiple bond, they are transferred to that atom to which the attacking reagent does not get attached. So Cn minus get attached to this particular carbon here. Okay, so at this position, your Cn minus get attached. So this is the negative E effect. So what are the points to remember here? So as inductive effect is a permanent effect, this is temporary effect. Okay, this is a temporary effect. So there is a formation of positive and negative centers. So you can see there is a formation of positive and negative centers on two ends of the bonds, and thus it results into dipolar ion. Dipolar ion. So because of the transfer of electron takes place, so there is a positive and negative centers are created at the two ends of the bonds. So this effect takes place between two atoms joined by a multiple bonds. So it takes place between the atoms joined by a multiple bond. So this is about your negative electromeric effect. Next is resonance effect or mesomeric effect. Okay, what is resonance effect or mesomeric effect? The resonance effect is defined as the polarity which is produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons, okay, which is present on the adjacent atom. So this is nothing but your resonance effect, or it is called as mesomeric effect. So what it is? So polarity is induced in the molecule by interaction of two pi bonds or between a pi bond and a lone pair of electrons. See here an example. So in this molecule, there are what? There are two pi bonds. Okay, you can see two pi bonds. So what is happening here? There is a transfer of electrons. Okay, there is transfer of electrons between the adjacent atom takes place. So from this pi bond, the transfer of electron takes place on the adjacent atom. So from here, the charge move to oxygen. Okay. So what you are getting? CH2. So what you get here? So it will be, so as the electron charges are moving, so this will be CH2 plus, right? So your CH, then from this pi bond is moving to adjacent. So here you get a double bond, then you get CH, and this is O minus. Okay, so like this, you are getting. So the polarity, how it is produced? It is produced in the molecule by interaction of two pi bonds. Okay, either two pi bonds or between a pi bond and a lone pair of electrons, which is present on adjacent atoms. So within a molecule, there will be one pi bond or two pi bonds or one pi bond and a lone pair. So between the adjacent atom, the transfer or interaction of two pi bonds will occur. Okay, and thus the polarity will be developed. So this is nothing but your resonance effect, or it is called as mesomeric effect. Next is, we'll see what are the types of resonance or mesomeric effect. So it is two types. First is positive R or plus M effect. So it is given as plus R or plus M effect. So when the groups or atom donates electron, so when the groups or the atoms donates electron to the conjugated system, it shows plus M effect. What do you mean by conjugated system? That is alternatively, when you have two pi bonds or one pi bond and a lone pair of electron, it is said to be a conjugated system. So when a group or atoms, okay, whenever the groups of atoms which donates electron to the conjugated system is said to be a plus M effect. So these are the group which shows the plus M effect. So this is the decreasing order of their resonance effect. So these are the group which shows your resonance or mesomeric effect. So whenever you have such groups, okay, whenever you have such groups or atoms in a mono-substituted benzene, what do you mean by mono-substituted benzene? What do you mean by mono-substituted benzene? So like this, okay, whenever you have a mono-substituted benzene, for example, okay, so like this, if you have a mono-substituted benzene, so what happens? So whenever such groups are present, so such electron donating groups are present, what it will do? So what it will do? So they are ortho and para-directed. They are ortho or para-directed. So either they will occupy this place or this, okay. So why? Because they increase the electron density on ortho and para position. So whenever you have electron donating group, so because of resonance effect, what it will do? It will, the electron density will be more at ortho and para position. So it will take this ortho or para substituted products will be formed. Why? Because at this particular position, the electron density is said to be high. So whenever you have electron donating groups, so plus M effect is shown. Whenever you have a mono-substituted benzene, it will undergo or it will show para or ortho substituted products. Next is minus R or minus M effects. So when the groups or atoms withdraws electron from conjugated system, so when they are said to be withdrawing the electrons from the conjugated system, it shows minus M effect. So these are the groups. Okay, this is their decreasing order. So you can see these are the group which shows minus M effect. So these are the group which withdraws electron. What do you mean by withdrawing effect? It will pull the electron towards itself. Okay, withdrawing. So these are the groups which will show minus I effect, minus M effect. Okay, so next is, so when such groups or atoms are present in a mono-substituted benzene, they will be meta-directed. So what is meta-directed? Okay, this is a meta position. So at this particular position, it will be, okay, so at this particular position, it will be what? It will be attacking. Okay, so whenever you have such groups or atom in a mono-substituted benzene, they are meta-directing because they decrease electron density at ortho para position by electron withdrawing group. So whenever such groups are present, electron withdrawing group, the electron density is decreased at ortho para position. So they are highly directed or they are meta-directed. Okay, so they will undergo meta okay, meta-directing groups. So these are meta-directing groups. So what is the application? So minus R effect, it increases the acidity of phenol and aromatic carboxylic acid. Okay, so example, para-nitrophenol is more acidic than phenol. So minus R effect. So when is minus R effect shown? Minus R effect is shown when you have electron withdrawing groups. Okay, electron withdrawing groups. So because of the electron withdrawing group, what it will show? It will show the increase. There will be increase in the acidity. Okay, acidity of phenols and aromated carboxylic acid. So example is para-nitrophenol is more acidic than phenol. Okay, para-nitrophenol is more acidic than phenol. So what is para-nitrophenol? So because of the presence of this nitro group. Okay. So because of the presence of this nitro group, what will happen? So the para-nitrophenol is more acidic than your phenol group. So because of this group. Okay. So next is what? Plus R effect increases the basic nature of amine. So para-methoxyaniline. Okay. Para-methoxyaniline is more basic than your aniline. So para-methoxy, because of the presence of methoxy group, okay, para-methoxy at para position, it is more basic than your aniline. So these are the application of your mesomeric or resonance effect. Next, so based on this, we'll solve some of the questions. So the arrangement of CH3 thrice C, CH3 twice CH, CH3, CH2, when attached to benzene or an unsaturated group in increasing order of electron releasing effect plus effect is. So what will be the increasing order? Yes, what will be the increasing order? So these are the groups. Okay, these are the groups. Increasing order, not decreasing, increasing order. Yes, increasing order.
Option B, ma'am.
Yes, option B, right? Option B is the correct answer. So based on the, see here only one CH3 is there. Okay, so here the number of CH3 is twice. So as you increase your electron withdrawing groups, okay, so it will be more. Okay, so this is the increasing order of the electron releasing effect. So this is the plus I effect. So B is the correct answer. Good. Next, presence of a nitro group in a benzene ring. What it will do? Presence of nitro group in a benzene ring. What it will do? What it will do? Presence of nitro or group in the benzene ring. Renders the ring basic, deactivates the ring towards the nucleophilic substitution, deactivates the ring towards electrophilic substitution, activates the ring towards electrophilic substitution. The correct answer is C. Okay. Deactivates the ring towards the electrophilic substitution reaction. Correct. Next, inductive effect involves. So what does inductive effect involves? What does inductive effect involves? Read out the options and tell me the answer. What does inductive effect involves?
Yeah, ma'am.
Yes, it involves a displacement of sigma electrons. Good, good. Okay, it involves a displacement of sigma electrons. Correct. Next, the basicity of aniline is less than that of cyclohexanamine. This is due to, yes, this is due to the basicity of aniline is less than that of cyclohexylamine. What is cyclohexylamine? Okay, there is no cyclohexylamine means like this. So the basicity of aniline is less than that of cyclohexylamine. So aniline is what? Aniline will be like this. A. It is due to plus R effect of NH2 group. Okay. So
Yeah, ma'am.
yes. So aniline is less basic than cyclohexylamine due to plus R effect. Okay. Because of plus R effect. So this is correct. Good. Next, plus R effect is shown by. So which of the groups will show plus R effect? Which of the groups will show plus R effect?
Ma'am, option B.
Option B, ma'am.
Correct. Option B, CH3. Okay, the other are Br, Cl, nitro group. These are all, it shows minus I effect. So only CH3 group will show plus I effect. So correct. B is the correct answer. Chloroacetic acid is stronger than acetic acid. Yes, this can be explained using which effect? Chloroacetic acid, one of the CH3 group is been replaced by what? Okay, so one of the this it is due to B. B is the correct answer. Okay, it is minus I effect. Minus I effect, right? So because of one of the hydrogen atom is been replaced by Cl, this can be explained using minus I effect. Okay, so there is minus I. This is Cl atom is a, so it is stronger. It is stronger acid than acetic acid. It can be explained by using minus I effect. Next, we'll see what is electrophile and nucleophile. Okay, so what do you mean by electrophile? Electrophile are electron deficient species, and nucleophile are having at least one lone pair of electron to donate. Okay, so these are electrophiles are electron deficient species, and nucleophile are these are electron rich species. Okay, they have at least one pair of electrons to donate. Okay, then in electrophile, they are positively charged electrophiles are present. So that is H plus, NO2 plus. So these are the electrophiles. And what are nucleophiles? Cl minus, Br minus, Or minus. So these are the examples of your nucleophile. These are negatively charged. Okay. Then what are the so neutral electrophiles are also there, like BF3, AlCl3, SO3, etc. Okay, so these are neutral nucleophiles, electrophiles. Then what are the examples of neutral nucleophiles, like water molecule, okay, ammonia. So these are the, so what do you mean by electrophile? These are electron deficient species. Nucleophile, these are electron rich species. Next, we'll see what are the method of purification of organic compounds. So crystallization, when do you do crystallization? Suppose we have we have extracted a compound. Okay, we have extracted a compound. So we have extracted a compound. Now we want to, so whenever you have extracted a compound, so there will be some impurities present. Okay, so we want to purify that compound. So how you will purify? So there will be different impurities. So what you will do for that, you'll see a solvent. Okay, you'll see such a solvent that the impurities and the your organic compound get dissolved in that. So what you do, you take the whatever the extracted organic compound, you add your solvent, you heat it, okay, and then you filter it. Okay, after filtration, whatever the impure or impurities are there, that will get into the paper, okay, the filter paper, and the filtrate, after filtering, the filtrate, whatever is left behind, okay, that will be a pure form. So that what you do, that you keep it for purification. Okay, what will happen? There will be development of crystals, right? So like this is the crystallization method. So what is done? What is the principle behind? Different solubilities of a given organic compound and its impurities are dissolved in the same solvent. Okay, and then you are purifying your compound. So whatever the compound you get, they will be in the crystal form. So that is nothing but your crystallization. So application is what? Sugar mixed with a common salt can be purified with ethanol. Ethanol is alcohol. Then sublimation. Sublimation is what? Directly your solids are converted into vapor phase. Okay, they do not go into liquid phase. Directly from solids, they are changed into vapor. So and vice versa on cooling. So this is used for solids which directly change into vapor phase on heating. Okay, so application iodine. So iodine from sodium chloride, as iodine they sublime readily. So it directly it can go from solid state to vapor state. Next is distillation. So distillation is used to separate volatile liquids from non-volatile impurities. Volatile liquid means what? Whose boiling points are less. Okay, which can, volatile means it will easily evaporate. Okay, then so whenever you want to separate two liquids, so you can which is one is volatile, another is non-volatile. So from that non-volatile impurities you can separate by distillation. Another is what, liquids having sufficient difference in their boiling point. So if the two liquids you are taken which have sufficient difference in their boiling point, then you can use this distillation techniques. For application, hexane and toluene. If you have a mixture of hexane and toluene, so you can see the boiling point, one is 342 Kelvin, another is 384 Kelvin. So first your hexane will come out and then your toluene will come out, okay, after distillation process. Next, fractional distillation. So if the difference of boiling point of two liquids is not much, okay, then you can use this fractional distillation. So where it is applied for crude oil in petroleum industry, okay, it is separated. So by this you can separate your various fractions such as gasoline, kerosene oil, etc. So these all you can separate. Next, steam distillation. So when steam distillation method is used, it is used to separate steam volatile, okay, then immiscible with water. So whenever your solution is immiscible with water or it contains non-volatile impurities. For example, if two these are there, okay, ortho and para nitrophenols are there. So like this, when ortho and mixture of ortho and para nitrophenols are there, so that time by steam distillation you can separate these two particular solutions. Next is differential extraction. Differential extraction is used for separating a organic compound which is present in the aqueous solution. So if you are extracted any organic compound which is in aqueous solution, so after adding some organic solvent, okay, whenever if you add some organic solvent to that, then what you can do by shaking it, okay, by shaking it there will be separation of two layers. One will be so your organic, whatever the organic compound is there, that will get dissolved into the organic solvent, and your impurities will be dissolved in it will be left over in the aqueous solvent. Okay, so like this you can separate your this organic compound. Okay, so the so whatever the organic solvent you have taken, so that will evaporate and you will be left with your organic compound. So like this you can separate your organic compound. So application is benzoic acid can be extracted from its water solution using benzene or ether. So you know ether is highly volatile. So if you mix the ether with your organic compound and you shake it with the aqueous solution, what will happen? So your compound will get dissolved. Okay, your compound will get dissolved in that, and whatever is left, so that your so after extracting your organic compound in the another this, so your ether will get dissolved. Okay, it will get dissolved or it will get away, so you will be left with your organic compound. So this is a differential extraction method. So next is chromatography. So chromatography is nothing but it is differential movement of individual components, okay, on a mixture through a stationary phase under the influence of a mobile phase. So this is nothing but it depends upon a two components. So one will be a stationary phase, another will be a mobile phase. So your if your mixture is having different components and you want to check its RF factor, okay, so then you have to dot them on a stationary phase, and then you have to keep them under the influence of a mobile phase. Then after after some time you can see that there will be movement of the different individual components. So by this principle you can find out your this. Okay, so this is widely used for what? It is used for separation, purification, identification and characterization of the components of a mixture, whether it is colored or colorless. So chromatography technique is nothing but you are whenever there is a mixture of any compounds, okay, you can separate it, okay, by individual components. They move with a different RF factor. So this is your chromatography technique. So the fragrance of flowers is due to the presence of some steam volatile organic compounds called essential oils. These are generally insoluble in water at room temperature, but are miscible with water vapor in vapor phase. A suitable method for extraction of these oils from the flowers is, yes, how the steam volatile organic compounds like essential oils, how they are separated. It can be separated by using the method steam distillation. Okay. By using steam distillation, it can be separated. So the correct option is D, steam or distillation. Which of the following is not a nucleophile? So which of the following is not a nucleophile? Yes.
A, ma'am.
A, correct. A is the correct answer. So next we'll see qualitative analysis. So, so these are some of the elements. So how, so Lassigne's test, right? What do you mean by Lassigne's extract? So these are some of the elements like carbon, hydrogen, nitrogen, sulfur, okay, so halogens. So these can be estimated by using qualitative analysis. So Lassigne's test. So what you do in Lassigne's test, you take your compound, okay, organic compound that is heated or that is fused with sodium, okay, you heat it till red hot. Then what you do, you plunge it in the water, okay, then you heat that container which is having water with the tube of the sodium extract, then you heat it, then you filter it, whatever filter you get, okay, you evaporate it, right, you heat it, you boil it, then the solution, then you filter it, whatever the filtrate you get, that is nothing but your Lassigne's test. So now if you want to test for copper, what is the test? You take cupric oxide, okay, you take cupric oxide and whatever the carbon is present in your compound to be detected, it gives you Cu plus CO2. So what will be the observation? CO2 gas turns lime water milky. Okay, if the CO2 gas turns lime water milky, then carbon is said to be present. How to detect hydrogen? So same cuprous oxide, what will happen? It reacts with your hydrogen. If it is present, it forms Cu plus 2 and water. So this water, whatever is there, these water droplets, if it turns anhydrous copper sulfate blue, if it turns blue color, then it shows the presence of hydrogen. Then for nitrogen, so nitrogen, what you're using? You're using a Lassigne's extract. Okay, Lassigne's extract. So Lassigne's extract is nothing but Na, right? You are fusing your Na with the carbon will be present. In organic compound, carbon is must. Then plus nitrogen, NaCN is formed. As NaCN is nothing but your Lassigne's extract. So this Lassigne extract, if you treat it with FeSO4 plus NaOH, okay, and you boil it, then cool it, then add FeCl3 and HCl. It gives blue or green coloration. If it gives blue or green coloration, it shows that nitrogen is present. Then for sulfur, how do you estimate for sulfur? So what? In Lassigne's extract, okay. If your compound is having sulfur, it gives what? Na2S. So if Lassigne's extract, if you treat it with sodium nitroprusside, it gives a deep violet coloration. If you get a deep violet coloration, it tells you that sulfur is present. One more test: if Lassigne's extract is treated with acetic acid and lead acetate, it gives you a black ppt. This also confirms that sulfur is present. So Lassigne's test is more important here. So your Lassigne's test, the preparation of Lassigne's test should be proper. Okay, then for halogens, Lassigne's extract plus HNO3, okay, nitric acid plus AgNO3, okay, a silver nitrate. If you get a white ppt, then it should be soluble in aqueous ammonia. This confirms what? Cl is present. Okay, chloride ion is present. Cl minus, that is chloride ion, is present. Then if it gives you a yellow preparation or yellow ppt, if you get a yellow ppt, then this yellow ppt will be partially soluble. It will be not completely soluble, but it will be partially soluble in aqueous ammonia. This confirms that Br minus is present. What is Br minus? Bromide ion. And if there is a third condition, if it shows yellow ppt, okay, a dark yellow ppt, a bit dark yellow ppt, if it is insoluble means what? It does not get soluble in your ammonia. It confirms that I minus, that is iodide ion, is present. Then if nitrogen and sulfur together, if you want to detect nitrogen and sulfur together, Lassigne's test plus ferric chloride, okay, ferric chloride, it gives you a blood red coloration. Important, this is an important test. So Lassigne's test, if you want to detect for nitrogen and sulfur together, okay, what is the test? Na plus C plus N plus S gives you NaCNS. Okay, this is nothing but your Lessines extract for nitrogen and sulfur. So this with ferric chloride, it gives you what? It gives you blood red coloration. So this confirms the presence of nitrogen and sulfur. Okay, so this is the qualitative estimation. So based on this, we'll solve some of the questions. The compound found in the positive test for nitrogen with the Lessine solution of an organic compound is, yes. So for nitrogen with Lessines, what it will give you? Yes, what it will give you? It is A. Okay, it is ferric ferrocyanide. Remember this? Okay, ferric ferrocyanide. So this is the correct answer. Ferric ferrocyanide. Okay. Sodium fusion extract obtained from aniline when on treatment with iron sulfate and H2SO4 in the presence of air, it gives you what? It gives you blue Persian. This is second one. So the compound found in the positive test for nitrogen with Lessine solution of an organic compound is what? Fe4, FeCN6, 3. It is nothing but what? It is called as ferric ferrocyanide. Okay. So the next, sodium fusion extract obtained for aniline on treatment with iron sulfate and H2SO4 in the presence of air gives you Persian blue precipitate. This blue coloration is due to the formation of what? Ferric ferrocyanide. Okay, A is the correct answer. So this is the other way of asking the question. Okay. Acidified solution or acidified sodium fusion extract on addition of ferric chloride solution gives red blood coloration. This confirms the presence of what? What it confirms you the presence of what? It confirms you the presence of N and
Yes.
nitrogen and,
Yes.
yes, nitrogen and sulfur. An organic compound which produces a bluish green colored flame on heating in presence of copper is. Okay. So the answer is A. Here the answer is A. So an organic compound which produces a bluish green colored flame on heating with presence of copper is A. So chlorobenzene, it produces bluish green colored this what flame on heating with presence of copper. This is when you're heating it in the presence of copper, it is called as Belstin's test. Okay, Belstin test. Next is quantitative estimation of elements in organic compounds. So here you can see carbon and hydrogen. It can be estimated by what? It can be estimated by Liebig's method. Okay, Liebig's method. So a known weight of organic compound is heated with excess of oxygen and amount of CO2, carbon dioxide and water which is formed determines the percentage of carbon and hydrogen. So this is Liebig's method. So amount of carbon dioxide, it determines the how much amount of carbon is there, and amount of water will tell you how much amount of hydrogen is present. So this is the formula. So remember this formula. Okay, percentage of carbon is calculated by 12 into weight of carbon dioxide into 100 upon 44 into weight. Okay, then weight given. Then this is percentage of hydrogen is 2 into weight of water molecule into 100 divided by 18 molecular weight of water into the weight given. So this is the formula to calculate the carbon and hydrogen. Okay, then next is nitrogen. How to calculate the amount of quantitative estimation of nitrogen? First is Dumas method. So elemental nitrogen is converted to molecular nitrogen, that is N is converted to N2 by a suitable chemical method and its volume is changed to STP data. So this is the formula. So you can see percentage of nitrogen is given by 28 into volume into 100. This is B is nothing but it is the volume of gas in L at STP. Okay, in liters in STP upon 22.4. 22.4 is the standard molar volume into weight given. So this is the Dumas method. So if they have asked to calculate the percentage of nitrogen by Dumas method, you have to use this particular formula. Next is Jalda's method. So this is Jalda's method. What is the process? Nitrogen in the organic compound is converted to ammonia. In Dumas method, you are converting the nitrogen into your elemental molecular nitrogen. Elemental nitrogen is converted into N2. Okay, N2, N2. Your nitrogen is organic compound is converted to NH3 by suitable chemical method, which in turn is absorbed by V1 ml of N1 H2SO4. Okay, so here actually excess amount of H2SO4 is used, but unreacted part is determined by back titration. So this is Jalda's method from, so this is the formula percentage of nitrogen. It is what by Jalda's method is given by 1.4 into N into V upon W. Okay, so this is the formula for calculating nitrogen from Jalda's method. Next is sulfur from Carrier's method. So sulfur in organic compound is converted into H2SO4 by boiling it with concentrated HNO3 and is precipitated as BaSO4. So your sulfur, it is converted into barium sulfate by heating it with HNO3 and barium chloride. Okay. So this is Carrier's method. So this is the percentage of sulfur can be calculated by this particular formula. Okay. Next, halogens can be also they can be estimated by Carrier's method. So halogen in organic compound is precipitated by as silver halide by boiling it with what? HNO3 and by adding AgNO3. So this is the weight. So for chlorine, 35.5 into weight of AgCl into 100 divided by 143.5 into weight of organic compound. So for Br with respect to weight of AgBr and the weight of AgBr here and the weight of the organic compound. So like this, you have to calculate the halogens using the Carrier's method. So this is the formula. Okay. So everything will be given. Only you have to substitute. Remember this particular formulas. Okay. Next, phosphorus can also be estimated by using Carrier's method. So Carrier's phosphorus is precipitated at magnesium pyrophosphate. So here it is precipitated as magnesium pyrophosphate. What is pyrophosphate? Mg2P2O7. Okay. So by sequential reaction with nitric acid, Mg chloride and mixture of ammonium chloride and ammonium hydroxide. So here this is the formula. Percentage of phosphorus can be calculated by 62 into weight of magnesium pyrophosphate into 100 divided by 222 into weight of the organic compound. Okay, this is the quantitative estimation of phosphorus. So this is one example in Jalda's method. Ammonia Okay, in Jalda's method, ammonia from 5 grams of food neutralizes 30 cm cube of 0.1 normality acid. The percentage of nitrogen in the food is, so percentage of Jalda's method is given by 1.4 into N into V divided by W. So 1.4 is given. So what is normality given here? Normality is 0.1. And what is the weight? Okay, what is the volume is given as what? V is volume. So volume is 30. Then what is the weight given? 5 grams. So 5 grams. So like this, you have to find the answer. Okay, so this is the answer. So this is Jalda's method. So you need to remember the formula. Everything will be given. Just you need to remember the formula. So this is, so by this we, one more question is here. Okay, so by this we complete our organic, okay, so some basic concepts of organic chemistry. So now we'll start with hydrocarbons. So what are hydrocarbons? Students, what are hydrocarbons? Yes, what are hydrocarbons?
The compound containing both carbon and hydrogen.
Yes, correct. So compound containing both carbon and hydrogens are together called as hydrocarbons. Okay. So are you able to see the slide of hydrocarbons?
Yes, ma'am.
Okay, so we'll start. So we have discussed the IUPAC nomenclature. So we'll not start with the IUPAC nomenclature. You know, okay, whenever you are naming any hydrocarbons, alkanes, right? Alkanes, alkenes, alkynes. So you're going to study about alkanes. Alkanes are what? They are saturated compounds. Alkenes, alkynes are what? They are unsaturated compounds. Why they are said to be unsaturated? Because of the presence of double bond and triple bond. Saturated, why it is saturated? Alkanes, because all are having single bond. Okay. So we are not going to discuss the IUPAC nomenclature. We have discussed the IUPAC nomenclature in the previous session. Okay, so here we'll start directly with the methods of preparations of alkanes. So we are going to start with the method of preparation of alkanes. How we are going to prepare the alkanes. So first is hydrogenation of alkenes and alkynes. What do you mean by hydrogenation? Hydrogenation is nothing but you are going to add hydrogen. Hydrogenation is addition of hydrogen, H2 molecule. Okay. And what is dehydrogenation? Dehydrogenation is removal of hydrogen, H2 molecule. So remember this, don't get confused. If it is hydrogenation, it is addition of hydrogen. So what you are doing, you are preparing your alkanes by addition of hydrogen in alkenes and alkynes. So here you see the first example is of what? Ethene. Okay, CH2 double bond CH2. When you are adding hydrogen, that is H2 molecule, so it will undergo hydrogenation. So it is what? Reduction. Addition of hydrogen across the double bond is what? It is reduction, right? So here what you are going to do, you are going to, so it will undergo hydrogenation in the presence of reducing agent like nickel, okay, or platinum or palladium. So H2 in the presence of either nickel, platinum or palladium, it will form what? Ethane. Okay, across this double bond, what you are adding? Across your double bond, you are adding your, okay, so here across your double bond, you are going to add. So remove this one bond is removed. Here you are adding one hydrogen. Here you are adding one hydrogen. So what it becomes? CH3, CH3. So addition of hydrogen across this double bond. Now here, so here what you are adding now? So from ethyne, okay, ethyne you are adding how many hydrogens? 4 hydrogens you are adding. So this is ethyne, CH triple bond CH. So when you add, first you add one molecule. First you add only H2. When you're adding one molecule, what it will form? It will form across one bond. So across, first you remove one bond, you will form what? CH2 double bond CH2. Then again, one molecule of H2. Okay, that is here you have taken how many moles? 2 moles of H2. So one more mole of H2, what it will be? Break this bond, what you will get? CH3, CH3. So when you want to prepare your alkanes from ethene, you require only 1 mole of H2. If you are preparing your alkane from ethyne, okay, that is from triple bond, you require how many mole? 2 moles of H2. So in the presence of what? Nickel, platinum, or okay, either of one to take, either nickel, platinum or palladium. So this is the first method of preparation. So the next is Woods reaction. Okay, what is Woods reaction? You take a alkyl halide. You take a alkyl halide. Alkyl halide, when it is taken with sodium, okay, you react with sodium in the presence of dry ether. In the presence of dry ether, it forms what? It forms alkane. Okay, a higher alkane is formed. There is increase in the alkane chain, and you have the sodium halide. So this reaction is used. It is used to increase the length. It is used to increase the length of the carbon chain, and this reaction is not suitable for preparation of unsymmetrical alkanes because cross products are also formed. So alkyl halide, so what is the alkyl halide is represented as Rx. Okay, Rx in the presence of sodium and dry ether. So remember, what is Woods reaction? Alkyl halide is reacted with sodium in the presence of dry ether. It gives you RR. So it gives you a alkane. So this is one of the examples. So this is unsymmetrical alkenes are taken. So there are two methyl bromide plus ethyl bromide in the presence of sodium and dry ether. It gives you propane, ethane, and butane. So these are cross products formed, okay, from unsymmetrical alkenes. So Woods reaction, important reaction. Alkyl halide reacts with sodium in dry ether, giving you a higher alkane. So next is Kolbe's electrolysis. Kolbe's electrolysis, what is the reaction? Sodium carboxylate. Yes. Yes, it is 2 moles of alkyl halides, right? So coal-based electrolysis. Okay, coal-based electrolysis is what sodium carboxylate. When you are electrolysis is what supplying of electricity. Okay, so electrolysis in the presence of water molecule, it gives you a alkane. So your alkanes which are formed will be of even number of carbon atoms can be prepared. So methane cannot be prepared by this method. So only alkanes with even number of carbon atoms can be prepared. So here what is sodium carboxylate, it undergoes electrolysis, it forms alkane plus carbon dioxide gas is liberated H2 plus NaOH. Okay, so this is coal-based electrolysis. So here the alkane and carbon dioxide, what is liberated? It is liberated at anode. Okay, so alkane and carbon dioxide is liberated at anode and hydrogen gas is liberated at cathode. So electrolysis is nothing but you are supplying the electricity. Okay, so sodium carboxylate from Grignard reagent. So next is from Grignard reagent. Grignard reagent. What is Grignard reagent? RMGX. Okay. Organometallic compound is nothing but they are called as Grignard reagent. RMGX. When you react with HOH. Okay. HOH. So your Grignard reagent, it reacts with active hydrogens like water, ammonia, alcohol, or amines. What it forms? It forms alkane. Okay. It forms alkane and your the side product formed will be MgOH X. Okay. So Grignard reagent. Remember what is Grignard reagent? Grignard reagent is called as organometallic compounds. Organometallic compounds. Okay. So Grignard reagent. So from Grignard reagent also you can form your alkenes. Next. Reduction of alkyl halide. Reduction of alkyl halide. So reduction, you are adding your hydrogen. Okay. So alkyl halide is reacted in the presence. So your reducing agents use as zinc HCl, then hydrogen iodide in the presence of red phosphorus, then hydrogen in the presence of palladium can be used. So these are some of the reducing agents. So what is the role of reducing agent? It reduces the and itself undergoes oxidation. So alkyl halides, they show reduction, that is 2 hydrogens are added in the presence of zinc HCl, it forms alkane. Okay, RH. So there is a replacement reaction taking place, and what is the side product is? Okay, it is hydrogen halide is formed. Okay. So these are some of the reducing agents which are used for reduction of alkyl halide. Reduction is nothing but addition of hydrogen. Decarboxylation. What do you mean by decarboxylation? Decarboxylation. Carbon dioxide is get a carboxylic ion here. See here. RCOONA. That is sodium carboxylate. When you treat it with NaOH. So this NaOH and CaO. Remember what is soda lime? Okay. What is soda lime? Soda lime, it is NaOH and CaO. Okay, what is CaO? Calcium oxide. So sodium hydroxide with calcium oxide is nothing but your soda lime. So when you react your soda lime with sodium carboxylate, there is what? Alkane formation. Decarboxylation means what? Removal of carbon dioxide gas. Okay, removal of carbon dioxide gas. So decarboxylation. Decarboxylation is removal of carbon dioxide gas. So soda lime is NaOH plus calcium oxide. So we'll see some of the questions. So when phenyl magnesium bromide reacts with tertiary butanol, the product obtained formed will be. Yes. What is the answer? So your magnesium bromide, phenyl magnesium bromide. So when phenyl magnesium bromide. So how do you write phenyl? C6H5 MgBr.
And benzene.
Yes. Plus your tertiary butanol. Okay, tertiary butanol is what? So this, what you'll get C6, H5, okay, H plus Mg, Br, O, C, CH3 thrice, okay. CH3 thrice. So this is the what you'll get. It will be benzene. So correct answer is benzene. So when phenyl magnesium bromide. So what is organometallic is nothing but Grignard reagent. Okay, organometallic compounds. Organometallic. So see, what is that? Organometallic. So for example, organo. So this is a organic compound is what? Mg. This phenyl is a organic compound, right? Metal is present. Mg is a metal. So it is a organometallic compound is nothing but your Grignard reagent. So Grignard reagents are said to be organometallic compounds. So the correct answer is your benzene. So this is the reaction. So next is on treating a mixture of two alkyl halides with sodium metal in dry ether, 2-methyl propane was obtained. The alkyl halides are, yes. So the reaction is so this is CH3, CH, CH3, Cl. Okay, 2-methyl propane, 2-methyl propane plus
Option A, ma'am.
Cl, CH3. Okay, you get in the presence of 2Na. Which is this reaction? What is the name of the reaction? Woods reaction, right? This is a Woods reaction. So the correct answer is A. So you are going to take what? You have to take 2 propane and 1 chloromethane to obtain your 2-methyl propane. So these are the two mixture of alkyl halides. So this is the correct answer. Yes, correct. Next, identify the product Y in the following reaction sequence. Yes, product Y. So you have to identify the product Y. So this is a reaction. So what you do, you heat it. Okay, you heat it. What is released is calcium carbonate. Okay, calcium carbonate. What is X here? X is your CH2, CH2. Then CH2, if calcium carbon, this is goes, calcium carbonate goes, what is left here? CO, right? Calcium carbonate, CaCO3.
Ma'am, option C.
Right. Then further you are reducing it in the presence of Zn, Hg, HCl. This is Clemmensen reduction. Okay, Zn, Hg in the presence of HCl. When you heat it, it is called as Clemmensen reduction. What is the Y obtained? So it is CH2, 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 and here CH2. Okay, so this is correct answer is C, cyclopentane. Correct. Good. Okay, this is the correct answer, cyclopentane. Methyl bromide is converted into ethane by heating it with ether medium with. Methyl bromide is converted to ethane by heating it in ether medium with. Methyl bromide is a alkyl halide. Okay, so it can be converted into ethane. Methyl bromide is converted into ethane by heating it with ether medium. So Woods reaction. What is Woods reaction? With sodium, right? Correct answer is C, with sodium. So which is the reaction? This is Woods reaction.
ಆ ಗ್ಲಾಸ್ ಎಲ್ಲ ಕುಡಿದ್ಯಾ ಆ ಗ್ಲಾಸ್ಗೆ ಕುಡಿದ್ಯಾ ಏನು ಮಾಡಕ್ಕಾಗಲ್ಲ
This is a Woods reaction. So methyl bromide is converted into ethane by heating it with ether medium with sodium. Okay, so this is the answer. Next, which of the following reaction can be used to prepare methane? Yes, which of the following reaction can be used to prepare methane? Clemmensen reduction, Woods reaction, Rosenmund's reduction, reduction of to methyl iodide by using zinc copper couple. So the correct answer is D. Okay. So methyl iodide, when you reduce, reduction is done by using what is reduction? 2H in the presence of copper and HCl, you get ethane plus HI. Okay. This is the answer. D is the answer. Okay, just read. Okay, just see the reaction. You'll come to know. Next, methane can be converted into ethane by the reaction chlorination followed by the reaction with alcoholic KOH.
ಏನು ಮಾಡ್ಕೊಳಕ್ಕಾಗಲ್ಲ ಏನು ಮಾಡ್ಕೊಳಕ್ಕಾಗಲ್ಲ
Chlorination followed by reaction with alcoholic KOH, chlorination followed by reaction with aqueous KOH, chlorination followed by Woods
Option
reaction.
C.
ಆಯ್ತು ಮುಚ್ಚ್ರ ಅವರೇ ಹೇಳ್ತಾರೆ
It is option is C. Okay, correct option is C. So how is the reaction? I'll write the reaction. Methane in the presence of Cl2 H nu will give you 2CH3Cl. Then in the presence of Na, in the presence of dry ether, okay, gives you CH3CH3. So this is the reaction. Okay, and this is the reaction. So next is, so we'll see some of the physical properties. So yes, it's time up now. So we'll see the physical properties in the next class. Okay, we'll continue with the hydrocarbons in the tomorrow's class. Thank you, students. We'll meet tomorrow.